In this video, we will learn the statement and proof of intermediate value theorem. I am writing the proof from the Rudin's book. Now, the statement of intermediate value theorem is statement let f be a continuous real valued function on the interval AB if f of A is less than f of B, then and if C is a number, such that f of A is less than C less than f of B, that means C is between f of A and f of B, then the conclusion is then there exists a point x0 in AB such that f of x0 equals to C. So, this is the statement. Now, graphically you can think this way. Suppose this is x axis, this is y axis, and you have a function. This is suppose function f, this is f, and this point is a, lower limit, and this point is A and this point is B. So, if this point is A, then this point would be f of A. If this point is B, then here it would be f of B. Now, here f of A is less than f of B, but if f of A is more than f of B, then we can prove similar way. Now, the theorem says if there is a point C between f of A and f of B, that means suppose C is here, this is C, then if you extend a straight line along x axis and then along y axis, then there will be a point between A and B which is x0. Okay. So, at this point f of x0 would be C. At this point f of x0 is C. This is the intermediate value theorem. Now, we will learn its proof. So, to prove the theorem, what we will do, put h of t. So, we assume h of t is f of t minus c, f of t minus c. Now, since the function f is continuous and the c is a constant, so f of t minus c would be continuous, that means h of t would be continuous. Since f is continuous on AB, then h is also continuous on AB. Now find h of A. If you plug t equals to A here, then it becomes f of A minus C, f of A minus C. Now if you consider this part, f of A less than C, then f of A minus C would be less than 0, f of A minus C would be less than 0. So this is less than 0. Now how about h of B? So if you plug t equals to B, then h of B would be f of B minus C. Now if you consider this part, so now we will consider this part. So here f of B is more than C, that means f of B minus C, f of B minus C is more than 0. So this would be more than 0. Now if you consider a function, suppose so at h of A its value is negative, less than 0, and at h of B it is positive. So suppose this point is A and this point is B. So this is A, this is B. Now at A, h of A is negative. Suppose this point is h of A and h of B is positive. Suppose this point is h of B. Now since the function h is continuous, so if we add those 2 points h of A and h of B, it has to cross the x axis because h is continuous. So since it has to cross the x axis, so at this point, suppose this is x0, so at this point h of x0 would be 0. Okay. So since the function, since h crosses the x axis, there exists x0 in AB such that h of x0 would be 0. Okay. Now if h of x0 is 0, then from here we can write f of x0 minus c equals to 0. That means f of x0 equals to c, and this is what we need. Okay, because f of x0 equals to c. So this completes the proof. Thanks for watching.